All right, here we go. Question number 14 from our 1316, homework number 2 in MyLab Math. They want us to find the amplitude, period, and the phase shifts, graph the function, yada, 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 more stuff. Okay, so here we go. Let's start with the standard equation of a sine function, which is y equals a sine of bx plus c. And then from here, we can tell the value of A, B, and C. So A is -6, B is going to be 3, and C is pi over 2. And now we can start answering some questions. Now, amplitude is the absolute value of A, okay? Whatever A is, I take the absolute value. That's my amplitude. Absolute value of -6 is 6. And we're going to plug that in and move on to the periods. For a sine or a cosine, the period formula is 2 pi over b. B in this case is 3. And that fraction will not reduce. So that's going to be my period as a fraction, 2 pi over 3. Bam. And last but not least, the phase shift. So the formula for the phase shift is -c over b. And our value for c is pi over 2. Notice when I plug that in for c, it's going to get the negative attached. So that's negative pi over 2 over 3, which is going to simplify to negative pi over 6. So that is our phase shift. And it's going to be negative as a fraction pi over 6. And then we can look at the graph. So we're going to graph this manually first, and then we'll graph it electronically. Using the 6-step method of graphing a sinusoidal function, step number 1 is the starting point, and that is determined by the trig function. Sine always starts at the origin. So we're going to go to the origin and put a big old dot. That's our starting point. Sine starts at the origin. Cosine starts at the number in front, at the value of A. But since we have a sine, we're going to start at the origin. That is step number 1. Step number 2 is the phase shift. If you have a phase shift, you have to deal with it now. Our phase shift is negative, so this starting point is going to shift to the left a pi over 6. Okay, so we're going to erase that starting point, and we're going to shift it to the left. It's no longer going to be at the origin. Now we're going to start at negative pi over 6, still on the x-axis, but the phase shift has to be dealt with at step number 2, okay? So now that we really know where we're going to start at, step number 3 is going to deal with the wavelength, which is the period. And the period has to be 2 pi over 3, okay? So I have a question for you. How many pi over 6 does it take to make 2 pi over 3? Okay, let's examine that. How many pi over 6 will it take to make 2 pi over 3? That's the question that needs answered. So we need a common denominator. Multiply by 2. 3 times 2 is 6, but I got to do the top times 2 also. And then 2 times 2 gives me 4. Okay, so that tells me that 4 pi over 6 will be equivalent to 2 pi over 3. And if you're wondering why do I need to do all that work, it's because that's going to tell me how many spaces to go. I'm starting at negative pi over 6. I need to go 4/6. Okay, so here's 1/6 to the origin gets me 1/6, and then 2/6, 3/6, 4/6. 1/6, 2/6, 3/6, 4/6. So this distance is 4 pi over 6, 4/6 pi, which is equivalent to my wavelength. That's why I need to do all that work, is to finish out where that first wave is going to end at. And so now I need to figure out what to label that. The endpoint has got to be labeled correctly. And to figure out what to label this endpoint, we need to count from the origin. Okay, now remember, every one of these spaces is 1/6 of a pi. So this is 1/6, 2/6, 3/6. So this would be labeled 3/6 pi. However, 3/6 will reduce to pi over 2. So really, we're going to label this pi over 2. And that's going to be my endpoint. Okay, now remember, you finish where you start. So if I start on the x-axis, I'm going to finish on the x-axis. That'll be my endpoint. Does everybody see what I'm talking about? This is one complete cycle. This is a period. One complete wavelength. And it had to be a distance of 2 pi over 3. And every one of these is 1/6. 1/6, 2/6, 3/6, 4/6 is my period. Okay, so I had to do all of that to figure out where to end at. Okay, now then, step number 4. I have to have 4 equal spaces. Well, from start to finish, I've got 1, 2, 3, 4. So I have my 4 equal spaces, and that takes care of step number 4. Step number 5 says lay out your points. I've got to lay out my points. And if we go back and look at the original problem, we see that the coefficient of the trig function was negative. So that means at my first hash mark, I'm going to have to be at -6. Okay, so starting at not the origin, starting on the x-axis, at my first hash mark, I'm at -6. At the next hash mark, I have to return to the not the origin. I keep saying origin. Return to the x-axis. And then guess what happens at the next hash mark? 1, 2, 3, 4, 5, 6. We're going to be up at +6. And then we're going to come back down. Okay? And so now we can go through and connect the dots. That is step number 6. Connect the dots. So going down, making a valley, and then making a hill. And that is one complete wavelength. That is one period. Now notice over here it says show at least 2 periods. Well, that's a piece of cake. If I just continue this graph out and continue my pattern here, I'm going to count another 1, 2, 3, 4 spaces, okay? And I'm going to continue to go down, x-axis, up, x-axis, and we get another complete wave. Okay, so there's 2 periods. Now, let's see if we can label some of these points correctly. Remember, each one of these hash marks is 1/6. So this point right here would be pi over 6 comma 0 because it's on the x-axis and the hash mark is 1/6. Okay, the next ordered pair would be at 2/6, but 2/6 reduces to 1/3, and that is up at 6. Okay, so the next ordered pair is at pi over 2 and 0, right there on the x-axis. All right, so let's count 1/6, 2/6, 3/6. What is 4/6? Well, that reduces to 2/3. So the next point here, the next critical point is going to be at 2 pi over 3 negative 6. 1, 2, 3, 4. The next ordered pair is going to be at 5 pi over 6 on the x-axis. And then the next one is going to be at 6 pi over 6. 6/6 is a whole. So at pi, I would expect to be up at 6. Okay, and then another sixth would be 7 pi over 6. And I'm going to be back on the x-axis. So we can actually label any of these ordered pairs if we know how to count by sixth and if you know how to reduce fractions, okay? Piece of cake. Now, let's look at Desmos. And let's clear this. And I want to show you that Desmos can be used to verify our hand-drawn graph. So we're going to type in the equation. Y equals negative 6 sine, S-I-N, 3x plus pi over 2. And so there is our wave, and we can verify some of these points, okay? So if I scroll this out just a little bit so you can see those. 0 is at negative 6. Was that on my hand-drawn graph? Right there. 0, negative 6. I didn't label that as an ordered pair. But the next one I did, pi over 6 and 0. There you go. There's pi over 6 and 0. Pi over 3 is at 6. We got that one. And you can, instead of dragging this out forever, I'm just going to click on a few more, okay? There's that one. We got pi over 2 and 0, 5 pi over 6 and 0, 7 pi over 6 is, I think, as far as I went. And then there's the 2 pi over 3 negative 6. So I want you to see how awesome Desmos is about taking your sinusoidal function. All you got to do is type that in. It's going to produce the graph, and then you can tell what each one of these critical points is going to be as an ordered pair. And that's going to verify what you do manually here. Okay, so now let's go ahead and finish this problem. We're going to graph in MyLab Math. This was a sine. So we're going to click on the sine tool and then click on the graph. Our amplitude was 6. Our period was 2 pi over 3. And our phase shift was negative pi over 6. Okay, so now I would like to point out that the original coefficient of the trig function was negative. And so anytime that number out front is negative, that's going to give you a reflection over the x-axis. So I am going to have to check that checkbox. Notice that that makes my graph flip over, and it's now at negative 6 on the y-axis, okay? And so that now verifies what we have over here. Okay, so we feel good about that, I hope. Bam, man. I hope all that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.